Okay, now let's move on to question 4, where we are given a small data set of complaints, each describing use two numerical features extracted from NLP analysis. These features represent responsiveness of the accused and support or gain due to infrastructure misuse. We are also given a query complaint, and we need to compare it with existing complaints using multiple similarity and distance measures. So let's go step by step with it. Okay, so we are given a query vector x equal to 1.4 and 156, and also the 5 complaint vectors c1, c2, c3, c4 and c5 with the given values. Okay, so our task is to rank the complaint by similarity using Euclidean distance, Manhattan distance, supremum distance and cosine similarity. Then normalize all vectors to unit length and recompute Euclidean distance. So let's begin with calculations. Okay, so ranking using Euclidean distance, its formula is t equal to root of x1 minus y1 square plus x2 minus y2 square. So we calculate each distance with our query vector and the complaint vector, and it turn out to be all these values. D with query 0.141, T with query vector and C2 0.671, T with query vector and C3, and so on. Now let's rank them in the ascending order. So first is C1, then second is C4, third is C3, fourth is C5, and fifth is C2. Moving on to the ranking using Manhattan distance, its formula is D is x1 minus y1 modulus x2 minus y2. So let's compute the distances with query vector and complaint vectors, and after calculating we'll get these values, and after ranking them we'll get this, and ranking and arranging them in ascending order. This will be our rankings. So now calculating the supremum distance. Formula for that is T of max mod of x1 minus y1 comma modulus x2 minus y2. Okay, so after calculating our distances we'll get this, this and this, and after calculating the rank we see that C1 is highest, C3 and C4 are tied, and C2 and C5 are tied. Okay, now ranking using cosine similarity. Cosine similarity measured direction, not magnitude. So the formula for that is it's given it here, cos theta equal to a dot b divided by this dot product of a and b and magnitude of a and b. So final rankings from the computation angles is coming out to be C1, C3, C1, C3, C4, C2 and C5. Even though C2 is far from the query in Euclidean distance, its direction is more similar than CY, causing it move ahead in cosine ranking. Okay, so after normalizing all vectors to unit length and decomputing Euclidean distance, when we normalize, we do this x equal to x by x mod, so that C dash will become C1 mod. Once normalized, Euclidean distance depend only on angles, meaning it becomes equivalent to cosine comparison. Therefore, normalized Euclidean ranking is equal to cosine similarity. Thus, the result so far becomes C1, C3, C4, C2, C5. Okay, so this completes the full analysis of similarity and dissimilarity between complaint profiles and using multiple distance metrics and normalized. So hope you find this video informative. Thank you. Have a great day.